Well, greetings, class, on this glorious Wednesday. Um, Hope you're all doing well. Today we are going to be talking about solving by taking the square root, woohoo, with real and imaginary answers. So you're going to get all sorts of weird answers. Now, if you are asked to solve, one thing I hope you don't forget about is that if it is possible to factor, you should definitely try to factor to solve whenever possible. Um, let's see. When you do that, you're always using the zero product property. That's that whole thing one, thing two thing, where you set it equal to 0, and then you factor, and then you set each factor equal to 0. Set each factor equal to 0. So that would have been step 1, step 2, and step 3. So suppose a problem looks like this one here. 2x cubed equals 40x. The reason I know this could be factored is because notice how there are two different powers of x. There's an x to the third and a regular x. Anytime there's two different powers of x, that's a dead giveaway that you're going to have to factor. All right, so let's see here. Move everything to the same side. 2x cubed minus 40x equals 0. Looks to me like I've got a greatest common factor of 2x, which leaves me with an x squared minus a 20 equals 0. And now we are going to do that whole thing one, thing two. So this is one possible factor. So 2x could equal 0, in which case x equals 0. Or our other solution could come from this factor equaling 0. So x squared minus 20 could equal 0, which would mean that x squared would equal 20. And now we're using those square root skills that we've been studying for the last day or two. So we're going to undo the x squared with the radical. And so we will get x equals plus or minus, don't forget that plus or minus, radical 20. And then, of course, if your radical can be broken down, you should do that. So this does break down, and I can bust out a 2. So my solution ends up being positive or negative 2 root 5. And this is what our answers are going to look like today. So let's take a look at a couple more. So far, when you have used the square root, it looks sort of like something like this. It looks pretty basic. There's one x squared term. On the other side, there's one number term. You basically do this, and then you definitely don't forget the plus or minus, and so then you get an answer like that. Today, it's going to look a little bit different. Today, it will be a little bit more involved. Now, when you look at a problem like this, a couple things I want you to think about. I want you to think about the analogy that I have used before, which is to unpeel the onion. And the onion here is, of course, the x. You need to get x by itself. That's what we're solving for. But there are lots of layers on top of that x. There is a 6 being subtracted, then that's getting squared, then it's multiplied by 3, then there's a minus 1, so there's a lot going on. The next thing I want you to be thinking about is that the parentheses, when they have a squared, are locked. So if they are locked, that means you cannot put anything in there. So for instance, doing something like this, where you put the 3 into the parentheses, that is so not okay. No, 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 no. All right, so let's see if we can't do this problem the right way. If we need to unpeel this onion, we have to pull the outer layer first. The layer that's most outer, I would say, is this one. Add that 1 over, you're going to get 3 x minus 6 squared is equal to 75. Now, I have another layer, which is this 3 here. I'm going to go ahead and divide that to the other side, divide it out of both sides, and I will get an x minus 6 squared is equal to 25. And now I can unlock my parentheses with a radical. And so there we go. And don't forget the plus or minus. So this is important. Woohoo! Yay, we're not going to forget that. Don't forget. Oh, oh, goodness. I've given up on this highlighter. It doesn't want to write for me. All right, so back to solving. We now have an x minus 6 equaling a plus or minus 5. Well, that's two possible things happening. Either the x minus 6 equals a positive 5, or the x minus 6 equals a negative 5. Now, those are two different scenarios, which means they give me two different answers. This first one here, if I add the 6 over, I end up getting x equals 11. That's one of my possible answers. For this one, if I add the 6 over, I get x equals 1. That is my other possible answer. So there you go. That is what you're going to be doing today. Now, I just want you to imagine doing that, but possibly having imaginary answers along the way. So let's see if we can't get one of those to look at. So just to review from yesterday, complex numbers have two parts. That's what makes them complex. The real part, and the real part always comes first. And then this is the imaginary part. And the imaginary part might be like a 5i or a 3i. And honestly, this doesn't have to be a plus in between. It could be a plus or a minus. So let's look at these two examples here. This first one looks relatively simple. All right, we are going to start by dividing by 5. And we will get x squared equals negative 36 fifths. Okay, that's not a very friendly fraction, but we can still work with it. All right, we're going to square root that x. And we now have a fraction under a radical, and not only is it a fraction under a radical, it's a negative fraction under the radical. So I'm going to do one thing at a time. First, I'm going to take care of that negative. So if I were to take care of that negative, it will come out of the radical as an I. So I will have I, and then I will have the square root of 36 over 5. So notice there is no negative on the inside of the radical. Now, the next thing I'm going to do is I am going to take care of this situation where I've got a fraction under a radical. So in order to do that, what I need to do is maybe split that up, give that radical to the top and the bottom. So far I have x is equal to I, and it's going to be square root 36 over square root 5. And some of this will simplify nicely and some of it will not. The top looks like it'll simplify nicely. I'm pretty much going to get a 6i on top, but then I have a radical 5 on the bottom. And the radical 5 on the bottom is also not proper. So remember that we've studied rationalizing in the last couple days. So now this skill of rationalizing is coming in step, let's see here, this was like step 1, step 2, step 3, step 4. The rationalizing is coming in step 5 of this problem. So don't forget that that's a necessary step. So in order to do that, I'm going to multiply by the conjugate. And I believe that's going to give us our final answer, which is 6i root 5 all over 5. And you know what, guys? I forgot something. Did you catch it? Did you see it? When I put in the radical, I forgot my plus or minus. All right, so that should have been here all along, and there it is. So those are your answers. Positive 6i root 5 over 5 and negative 6i root 5 over 5. All right, so then let's look at this next one and see how this might be similar and how this might be different. Okay. I have, in this case, a set of parentheses. So sometimes I'll do something like this, just as a reminder that this is locked. I cannot put that 2 to the inside of the parentheses. So instead, I'm going to divide it away. And I will get an x plus 1 quantity squared equals negative 18. Now I can unlock my parentheses with the radical. Oh, I'm not going to forget the plus or minus this time. All right, the radical and the squared undo each other, which just leaves us with an x plus 1 on the left side. And on the right side, let's see here, an 18. I can break that down to a negative 1 and an 18. Then I can break the 18 down to a 9 and a 2. So I believe this is going to become plus or minus 3i with root 2 left behind. And in our last step, if x plus 1 could equal positive or negative 3i root 2, then that's 2 possible answers. Now, I need to make sure that I get rid of this 1 so that I can get the x by itself. So I'm going to subtract the 1 over. But let me show you with my highlighter. This piece and this piece are not like terms. So this is a complex number. So our final answer here in proper complex number format is going to be the negative 1, which is the real part, plus or minus the 3i root 2. And that is our final answer. Okay. So it might get a little bit harder, like on this problem. I think the curveball here on this problem is really just this 1/2 right here. But that's not so bad. You're just going to divide by a 1/2. And you would end up with an x minus 5 quantity squared is equal to a 12. And then you would continue with your normal solving processes. So square rooting that, plus or minus. And then you get an x minus 5 equals positive or negative, if I break this down, 4 and 3, 2 root 3. And in my last step, add the 5 to the other side. Are you having fun yet? So my final answer is 5 plus or minus 2 root 3. And there we go. Remind me sometime to relate this to the quadratic formula. That's coming soon. All right, and last but not least, we've got several layers on this onion, if you will. So we need to get that 4 over first. 3 quantity x plus 2 squared is equal to negative 4. Then I'm going to divide by the 3. And I will get x plus 2 quantity squared is equal to negative 4/3. So this one's going to be kind of a gnarly problem. If you haven't quite figured it out, what's going to make it slightly gnarly is this right here. Not only is it negative, but it's a fraction. So when I do my next step of taking the square root, I have to, let's see here, what is the things I have to do? I am going to have to rationalize. And then I'm also going to have to take out the I. And so watch for that, you know. X plus 2, can't forget my plus or minus, is equal to plus or minus. I'm going to do a couple things here all at once. I am going to apply this radical, so I'm going to kind of do this. Apply the radical to the top and the bottom, which is going to give me a 2i on top and a radical 3 on the bottom. Then I am going to rationalize. So this whole thing is going to become 2i root 3 over 3. And I am really close to having my answer. Let's see here. I still have an x plus 2. on the left side, but now it equals this thing, plus or minus 2I root 3 over 3. And then in my last step, I just subtract my 2 over. So here comes my 2, which is my real part. My imaginary part was already on the right side of the equal sign. So my final answer is a complex number. It's got a negative 2 as the real part, and then a plus or minus, and then a 2I root 3 over 3 as the imaginary part. And there you go. So, lots of steps to these problems. Go slow. Remember things like rationalizing and imaginary numbers. Here are some major points. The square root comes with a plus or minus. As you can see, it's easy to forget that. Number 2, the parentheses are locked if they are squared. So no numbers can go into or out of the parentheses until you square root the quantity. Number 3, isolate the squared quantity. So, get the part that looks like this by itself. That's what you want to isolate. And to do that, you unpeel the onion. And number 4, denominators should be rationalized, all radicals and imaginary numbers. So if you had imaginary numbers in the denominator, those should be removed. To be honest, I don't think this actually happens on these problems. Not on these. You will get imaginary results, but there's no reason that the I should be in the denominator. All right, best of luck on your homework, and I will see you on Friday. Ciao.